Okay, so I wrote a script to create 2700 bytes of hex data. The idea here is for us to locate. The objective is for us to locate the EIP instruction pointer and then to craft an offset that will enable us point to a specific shellcode that we will craft actually. So that is the idea here. Since we can override the EIP, we can craft a specific code of 4 bytes that will point to the malicious or the address that we have our shellcode. So we will use the script called pattern create. We will locate it first. Locate pattern create. Great. This is a metasploit tool. -h to know about it, like a help. They said we use with -l argument, so we will use -l, and we want 2700 byte. This will enable us have a specific hex on the at the EIP level, so that we can look for the byte location of that EIP level. So let's modify our code once again. Great. Okay. So we can run it to see how it will stop or crash this SLMAIL, and then we will collect the address. Great, it crashed. So this is the address of the hex address of EIP. We will use another script called pattern offset. We will need to locate it. Locate pattern offset is still a metasploit Ruby file. -h to know about the arguments. We use -q for query. So we want to query this offset to know at what byte location this EIP address starts. If we know that byte location, we know that after that we have 4 bytes, because we have the 4 bytes that occupy the offset. So we can craft this after the 4 byte, we can craft the 4 byte into a specific address that we want. So we will locate query for 4396944. This will locate it for us, and we can go ahead for the next 2607 byte. Great. So we will still modify this code to make sure that at that level, let's put some random A's. Okay, we want to put 2607 byte. So this is where the offset starts. Then we concatenate this with a certain 4 byte of B to see if it occupies. Our aim is to discover the location of the EIP, the offset, so that we can craft our shellcode, because we are creating a shellcode from scratch. So this will be, remember, for this to crash, for the SLMAIL to crash, we need 2700 bytes. So we have here 2604 plus 4 and 7 plus 4, which is 71. So we need 81. So it's 11. 2611. So we need 789 to make it 69 actually, because we have 11 plus 69. Yes, let's put it plus C, the remaining ones, 69. Okay, sorry, 89, because we want to go to 700, so 2700. So let's save and rerun our code, but we first need to restart SLMAIL server and SLMAIL server and the debugger. Stop. Start. Great. Here again. Start. We attach it. SLMAIL. It's loading. Great. Okay. So let's run and discover our byte location. Sorry, we need to start always. When we restart everything, we need to start it so that it can run before we can run our exploit. Otherwise, it won't go. So let's run. Great. 42. The hex equivalent of B is 42, and the one for A is 41. The one for C is 43. So we realize that EIP has been flooded with the 4B we crafted specifically, and the rest was CCC, which is 43. Excellent. If we even follow the dump of ESP, follow in dump, we can realize with our bare eyes that we have A, and then we have 4B here. So this is our offset. We know that now because it is exactly on EIP and it's 4 byte. Our aim now is we know that these 4Bs constitute exactly the 4Bs that we want the offset of EIP to be. So now let's craft a shell, but before we need to increase the size of our memory. So we add, for example, 3000 up to 3500 to see if it can override much more space, so we can put our shellcode. So let me add, instead of 89, I will add 3500 minus sorry 3,500. In order to make it equal, we need to remove the 2,607 and the 4 byte. Now we are sure that it is 3,500. We can close, restart our SLMAIL. Attach our script software, a binary file. Great. We'll run our shell to see if it. Oh, sorry. We still need to restart our software. There is an error. Indentation. Okay, at the try level. Try should not be indented. Great, so let me run this. Perfect. Still at 444, but this time around, if we follow the dump, we realize that a lot of space has been covered with the great. We see a lot of C is showing here. It means that we have we succeeded to increase the size of our buffer. So let's now move quick and create a good, well-crafted shell code, but we will need to know using Moana script from Immunity Debugger at what level we need to start the jump ESP, because the jump ESP here will enable us to jump from the original memory location or instruction to our own shell code. For this, I will need to add shell code on the. Let me restart SLMAIL. Is it started? SLMAIL. Okay. Start. You remember I talked about Moana script that was very good for Immunity Debugger. This is where we are going to use the Moana script. You can find the Moana script online. They have a GitHub repository. You just look for Moana script, Moana.py on Google, and you can find the location. So you can put the Moana script in Immunity Debugger in the directory py commands. Py commands, you put moana.py. Once you put moana.py, we need to now, in this, find then where is our crafted code? Because this, okay. The next step is we need to use, for example, the Moana script that is already present. We need to load the binary. We need to load the binary and find a DLL file that is having ASLR disabled, and depth disabled. Why ASLR and depth? ASLR, spelled as ASLR, stands for Address Space Layout Randomization. it helps to randomize the offset location. It's a security measure that makes buffer overflow very difficult. But in this case with SLMAIL it was not set. DEP is data execution prevention. It prevents execution of data in particular memory region. So if we want to execute a shellcode and then DEP is disabled, it will be possible. But if DEP is enabled, it will not be possible. So the reason why we need to use MonaScript is because MonaScript leaves us the flexibility to scroll through the binary and have what we want, for example. Okay. So let me continue to the next step.